Hey, this is Nick Karnick, and you are watching Data Structures in JavaScript. Today we are going to implement the queue data structure in JavaScript. A queue is a simple linear data structure which is a container of objects that are inserted and removed according to the first in and first out principle. Elements can be enqueued from the back and dequeued only from the front, similar to a queue at a grocery store. Alright, so let's dive into some code. We've created a file called queue.js. Let's go ahead and add a node class to it. We're going to create a constructor which takes a parameter called value, and we will store this value internally in the value attribute. Each node in a queue will point to another node. So we need to create this .next and initialize it to null. Alright, that's it for the node class. Let's create the queue class with a constructor and initialize two attributes called front and back. We will set these to null. And basically they represent pointers to the front and back of the queue. Now let's create a method called enqueued, which will push elements into the queue. It will take a parameter called value. And before we get into the implementation, let's write some pseudocode here. First, we need to create a new node with value. Then, we need to check if queue is empty. And if it is empty, we want to point the front and back pointers to the newly created element. Or node. Else, the queue is not empty, so we will push the node to the back of the queue by pointing the last node to the newly created node. Now, our back pointer is still pointing to the previous node, so we need to move the back pointer to the newly created node. Let's start filling up some code here. So, we're first going to create a new node with the value that's coming into the function. Next, we want to check if the queue is empty. Now usually, it's a good idea to create some helper methods for these kind of things, because you may want to reuse that functionality. So let's create a method called isEmpty. So the queue is considered to be empty if this.front is null. So we need to return this.front is not null. Alright. So we're going to call if this.isEmpty here, and if that's true, we will end up pointing this.front and this.back to node. Now this is a perfectly valid statement. Both front and back end up pointing to node. Else, the queue is not empty. In that case, we will push a node to the back of the queue. We do this by setting the back pointer's next value to the current node. So this.back.next equals node. Prior to this, back.next is pointing to null because the last element always points to null. By setting back.next to the newly created node, we're creating a new last element. So we also need to move this dot back and point it to the newly created node. And that's what we will do on the next line here by setting this dot back equals to node. And I messed up the comments here. I meant to do this there. So we're pushing the node to the back of the queue by pointing the last node to the newly created node. And then we're moving the back pointer to the new node. All right, let's go to our index.js and try to test what we've created. So I'm going to start by importing queue from queue. And then we want to create an instance of that queue, followed by enqueuing values. So I'm going to enqueue 3 values here, 1, 2, and 3. And notice we're getting some error here. That's because I forgot to export the class. So going back here, I'm going to export it as default, since that's the only class that we need to reference outside of that file. And all right, notice that the errors are gone, but we're not seeing anything. So what we should do is create a print method, which will allow us to view the contents of our queue. And at the end of this, we're going to call this.print so that it prints the status of the queue. So there are mainly 2 conditions that we need to handle here. One is if the queue is empty, and the other is when it's else it's not empty. Now when it's not empty, we need to iterate through each of the elements and print their values. Now the way console.log works, we will end up with a value on each new line. So instead of that, we should print everything on a single line. In order to do that, we will create a temporary array, and we will assign a temp variable to the front of the list, to the front of the queue, sorry, followed by iterating through the queue. So we're going to iterate through the queue, add value into temp array, and then move to the next element. And finally, we want to print the values. All right, so let's go ahead and implement this. So if the queue is empty, we need to print empty queue. So let's use our helper method from up there, is empty. And if that's the case, we're going to console log empty queue. Okay, else it's not empty. And in this case, what we're going to do is simply fill in the values here. So let's create a temp array and initialize that. And we'll create a temp variable which points to the front of the queue, which is this dot front. And we need to iterate through the queue. So we will do that using a while loop. So while temp has a value, we will try to extract all the values from the nodes and iterate through those. So essentially we need to push the value of the current node into the temp array. So we do temp array.push temp.value, followed by moving temp to the next element, which is simply pointing temp to temp.next. Finally, we want to print our values here. And we'll accomplish that by simply doing console log temp. Since it's an array, we want to print it as a comma separated list of values. So I'm going to add, do a join here with a comma. And oops, I meant to do temp array here. And there you go. All right, so we have our values being displayed here. So every time we enqueue a value, a new row is printed with the elements in the queue. All right, now let's go ahead and create a dequeue method. This method will pretty much remove elements from the queue in the order they were inserted. So we need to start with a pointer to the front of the queue. And check if the queue is not empty. Then we need to move to the next element, move front to the next element. And one of the edge cases here is that if front was at the end of the list, pointing front to the next element will set it to null. So we need to then check if front is null. In that case, we want to move back to null, rather set back to null, so that both the pointers are pointing to null, indicating that it's an empty queue. Finally, we should print our list to show that elements are being removed, and then we will end up returning the node at the front of the queue. All right, so let's go ahead and fill in the code here. Now we need to create a pointer to the front of the queue. Let's create a node variable that points to this.front. And the next thing is to check if this.queue is not empty. In that case, we will move to the next element. So we will set this.front equals this.front.next. This is pointing it to the next element in the queue. And we also want to check if this.front is not past the end of the queue. If it is past the end of the queue, we need to set this.back to null. Finally, we need to call this.print so that we print our items in the queue, and we will return the node that was pointed to at the beginning of the function. So let's go back to our index.js file, and we're going to call the dequeue method a few times, 3 times precisely. And notice that we're printing something out here. So every time a new element is added, the queue keeps increasing. And as we remove elements from the queue keeps decreasing. And finally, it's printing empty queue because the last element was dequeued. Another thing we could do to make it clearer here is add a console log which prints the value being enqueued. And notice that as I'm enqueuing a value, the length of the queue keeps increasing and the order is maintained. And similarly, I'm going to print a message here. As we dequeue, I need to do it right there so I can reuse the node pointer. And then I want to print the value for node. And I need to do this if node is not null, else nothing, I guess. All right, so we have enqueue1, enqueue2, enqueue3, and the list keeps growing from 1, 2, and 3. Then we have dequeue1, 2, 3, or we're just calling dequeue, and it basically removes the element at the front of the list. So 1 gets removed here, 2 gets removed there, and 3 gets removed here. And finally, it prints empty queue because there are no more elements. Hope you enjoyed this video. If you have any questions or comments, write them below and subscribe to my channel to be notified of future videos. Thank you.